discuss. So basically, the shortage job for scheduling algorithm associated with each process, the length of the process is next CPU burst. When the CPU is available, it changes to the process that has smallest next CPU burst. You can show the slide, then I'll tell you something more detail about this one. Look at this example. You can notice over here the process P1, P2, P3, P4 have burst time 6, 8, 7, 3 respectively. So as I told you, the purpose of this algorithm to associate with each process the length of the process next CPU burst. When the CPU is available, it is assigned to the process that has the smallest next CPU burst. So if the next CPU burst of the two processes are same, then we need to apply the first come first serve, or we can say the first FCFS scheduling algorithm that is used to break the time. So you have to keep in mind the point. More appropriate term for this CPU scheduling, we would used, or we have to use shortest next CPU worst algorithm. So shortest job first scheduling algorithm is also known as shortest next CPU worst algorithm. So in the examination, these kinds of questions comes while written by the different name of the scheduling, just like shortest next CPU burst algorithm. So you should not have any kind of the confusion, which are also same name, that is a shortest job first scheduling. So you can notice in our example, even very clear example was telling to us process P1 has the burst time 6, process P2 has 8, process P3 has 7, process P4 has 3. The process P4, process P1, P3, P2, you can notice. So order are changed. It is not order is not into the sequential order as we have noticed into the FCFS. So waiting time of the process P3 is 7, process P2 8, P1 6, and P4 3. So you can notice which process we should take first. That is a P3 only. So you based on the their worst time, we will need to pick or choose the minimum worst time based process. So here we have to choose the process P4 first, and then its next process which is having the smallest next CPU burst time. So here we have P1, and then P3, and then P2 as well. So we have to solve this problem like this, which is mentioned in front of you, so we can understand. I'll tell you how to solve the problem. I tell you everything, but everything is mentioned in front of you, so you can easily understand. So I'll solve this problem by the two different approach, so you can easily understand by my style how I can try to how I can solve this problem. Solution is in front of you, but you need to understand the solution by my explaining way. So let me take this idea in front of you, then you need to tell me how to solve the problem. Okay, this slide is available where the CPU and burst time is mentioned over here. The CPU processor and burst time is mentioned over here. It is visible to everyone.
Yes, sir.
Okay, so I was talking about the shortage job first. So let me complete my statement. The shortage job first scheduling algorithm is also known as the shortest next CPU burst algorithm, because scheduling depend on the length of the next CPU burst of the process rather than its total length. So let me solve this problem by the shortage job first. First, I want to solve this problem by the FCFS, and then we'll try to solve this problem by the shortage job scheduling. Okay, so you can solve this problem along with me. Let us solve the problem by FCFS scheduling. So as you know, the problem can be solved by the Gantt chart. So I'm just making or drawing its Gantt chart. So as per the our concept, P1 will come first, and then P2 will come, and then P3, and then P4. So as you know, the starting time of the P1 would be 0. So no need to speak again. So the P1 will take the 6 milliseconds. So after its execution, 6 will finish over here. So P2 has to wait for the 6 millisecond for starting its execution. And now later on, the process will go on like this way. You can notice over here. And now you can go like this way. And now this one. So average waiting time of this process would be average waiting time of this process will be 0 plus 6 plus 14 plus 21 divided by 4. So what we are getting? Can anyone tell me what we are getting? 0 plus 6 plus 14 plus 21 divided by 4. So can anyone tell me what we are getting?
So 10.25 milliseconds.
10.25 millisecond. Super answer we are getting from the students. Now let us solve this problem by the shortage job first. So the difference between the shortage job first and SGF, it will be clear to you very easily. Now here, now I'm just writing here. Let us see the solution by shortest job first. In shortened way, I can write SJF. Then you can notice over here, with the help of the Gantt chart, I can draw Gantt chart like this way. Now you know the answer. So you can notice the P4, the process which is having the lesser or least burst time. So we have to choose or pick first this process. P4 I have chosen. Next process, what I have? Next process, we have P1. So I am choosing the P1. And then, which is next one, that is the P3, I'm choosing. And next, which is P2. So undoubtedly the shortage job we have. So here what we can do for understanding purpose, we can put a remark over here. This would be the on the first will be selected. This will be second position. This would be the third, and this would be the fourth. So we can say we are just temporary purpose. I'm explaining only. We are just assigning the rank of the all the process based on their worst time. This part for understanding purpose only. It is not mentioned in any book, so don't write like this way. But for explaining purpose, I'm writing here only. The process P1 will start first, so its waiting time will be, or we can say its start time would be 0, and it will take 3 milliseconds, so it will be finishing by over here. And then process P1 will start, so it will be finishing by here 9. And then process P7 will start, so that would be uh, what we have 9 plus 7, that is 16. And now here we have a 824. So you can notice over here, the dear students, you can notice over here everything I'm solving in front of you. So most of the concept will clear in your mind very easily. So if we need to calculate the average waiting time, either you can take the like this way, or you can take the process P1 having the waiting time is 3, process P2 having the waiting time 16, process P3 having the waiting time 9, and process P4 having the waiting time 0. And I need to divide by 4, so I can get it the answer. You can tell me the answer. It's very
7
yeah.
milliseconds.
Let me calculate once again over here in front of you. 3 plus 16 plus 9 plus 0. So I'm getting 7. So here I'm getting the 7 milliseconds. So you can notice over here the FCFS scheduling algorithm has the higher waiting time than the SGF. So conclusively, you will not choose the FCFS. You have to choose SGF because it has lesser waiting time than the FCFS. So if you choose this one, then your waiting time will be lesser compared to the previous one. So the purpose of this idea to understand how the operating system will apply such scheduling algorithm to execute all the instructions into the machines only. I told you multiple times everything is in our machine into the form of the instructions only. So we need to understand this problem like this way. So far, what the portion we have covered, is it clear to everyone?
Yes, sir.
So here I want to tell something more before moving to the next point. Shortage of for scheduling works on the process with the shortest worst time or duration. As you can notice over here, here we have 3, 6, 7, 8 like this way. So this is the best approach to minimize the waiting time. So now in our example, we have minimized the waiting time. FCFS we have the 10.25, rather in the 7 we have under the shortage offers. So this is used into the batch system. It means shortage of scheduled algorithm used in the batch system, and it has a two type or two flavor. One is a non-primitive and primitive. So primitive, I told you what is mean by the non-primitive primitive. So we will continue. Don't worry about this one, but we need to understand it has a two flavor. One is SGF with the primitive, SGF with the non-primitive. So to successfully implementation it, the worst time or duration of the process should be known to the processor in advance, and which is practically not feasible all the time. So how the processor will know the particular process will take such time? So theoretically we can speak, but practically it is not feasible because we don't know which process will take how much time. So point we have to remember, to successfully implementate the first time of the process should be known to the processor, but we don't know how it is possible to do so. So this is practically we can say it is not possible. So but we have to understand the concept. That's why we are over here. So this scheduling algorithm is optimal if all the job or processes are available at the same time, rather arrival time 0 for all. So you can notice over here the arrival time for the all the processes, as we can see into the Gantt chart. The scheduling doesn't mean it could be the FCFS or SGF so far what we have seen. The arrival time of the all the processes are 0 only. And if we have arrival time, individual arrival time for the each process, so our process may interrupt by the other process because other process may have a high priority or may something else. That part we'll see. So you have to keep my words over here. The shortest first scheduling algorithm has two type of the flavor. One is a non-primitive, other one is a primitive. So non-primitive scheduling algorithm you can solve undoubtedly. Here we have a very simple question. I want to share one question to you, and you need to tell me the what would be the answer of the question. So non-primitive shortest job first is nothing very simple. What is the purpose of non-primitive cooperative scheduling algorithm? When the process is assigned to the processor for its education, then it will complete its education first, then other process may allow to do so. Order doesn't mean we are selecting the order into the sorted job first based on its worst time. But once the process P1 or P2, whatever the process we have, come to the system for the education purpose, it will be executed completely. It will not execute partially. When the process execute partially, then preemption happen. So as a name suggests, preemption means when the preemption means the execution of the process will be into the partial manner only. So last state of the process may be stored or saved by the PCB, as we have seen the diagram, that is process control block. So when the process control block will identify that this process will call by the again for its execution, then it will keep its state, and it has a two state. One is a save state, other one is a reload state or restore state. So when this process or the any other process which is already under the partial committed or partial educated, that would be called again. Then it will take the operating system will take care by the help of the PCB what was the its last state and restart the same process from the point where it was left out. So this is a primitive idea you have to remember, my dear students, always. But I'm speaking very simple form only. So by the time with the help of the other examples, you may definitely understand. So non-primitive shortage job first, what we have seen, that is also known as a non-primitive shortage job first. So algorithm could be primitive, algorithm could be non-primitive, but we need to identify when it could be primitive, when it could be non-primitive or primitive. So one by one we'll see. No need to just take a very fast step, or we can say the very long step. We will take the slow step or to understand our concept only. So here I'm suggesting to the student you can solve the problem and then tell me the answer. What would be the answer of this one? Consider the below processes available in the ready queue for the education with arrival time 0 as for all the bus time. So you need to calculate the average waiting time of the given questions. You have to solve this question. I'll give you the 5 minutes. You can solve this problem. The question is clear right now. Tell me yes or no. The question is clear.
Yes, sir.
Okay, can you solve this problem? Or the I'm just suggesting to all the students just solve this problem and type your answer into the chat box, or by sending the message in call message. I can just check the answer from the all the students. I'm giving the 5 minutes. This is a very childish question. I'm sharing with all the people. You have to solve this problem.
So 2.66 milliseconds.
My dear, don't be panic. Be relaxed. Just calculate the average waiting time. I'll ask her, or you may type into the chat box or in call messages. But answer is wrong. Okay, so let me inform you. Answer is wrong. Whatever the value you are getting, you may do the wrong calculation. Check it once again. Okay, more than 5 minutes is over. So solve the problem. So what is the answer we are getting? 2.33. Ritu, you are getting the 2.33. How? You can check if the calculation answer is wrong. And the people who are getting the 4.5, tell me how they are getting the 4.5 milliseconds. Okay, if you have solved, if you don't have any doubt, you may we can continue. Else, you may ask the question. Look at the solution. Those who are still have a doubt, they may see the solution. Process P4 will execute first, then process P2, and then process P3, and process P1. So your average waiting time, we're getting the 0 plus 2 plus 5 plus 11. So that is the 4.5. Your solution is matching with this point. Tell me yes or no. Or anyone who is not getting the answer. Let me know right now. Anyone who is getting different value, you can check the solution over here as well. Shall I continue? Tell me yes or no. The solution is visible. Okay, tell me yes or no. So shall I continue to the other problem?
Yes, sir. Yes, sir.
Okay, so now you got the solution. You got the this algorithm, that is the shortest job first. So now with our example, you have also noticed what is the difference between the shortest job first and FCFS. So far we have seen the two scheduling algorithm, and these two scheduling algorithm we have covered some portion by which we can identify shortest job first is better than the FCFS so far. But this FCFS belong this shortage job first belong to the non-primitive. Non-primitive means once the process just enter into system for education, its education will be completed. No other process will be interfere. But when the other processes are interfering to the other processes, then we have a primitive. So we have the word primitive. So let me go to the such point, then you can understand. So what is the problem with the non-primitive? Let us me explain. So you can notice in this diagram, there is a problem with the non-primitive shortage job first. If the arrival time of the processes are different, which means all the processes are not available in the ready queue at the same time. It means suppose one student coming to here and multiple students are coming, so they're coming on the different time. If all students are coming on the same time, then we can choose the student who has minimum time to take the signature, so we can give the priority to the student. The student may give a chance and he or she may go. But some student coming their different time, and all students having their own work. Some students coming very lately, but the student may take only the 1 second, or maybe the 2 minutes max to max we are assuming. But the student who is coming first, the first student may take the 30 minutes. So in such scenario, there is a problem. So we have to see all these things by the non-primitive shortage job first problem. The problem with the non-primitive as yeah, we have, what is the problem we have? Let me speak again. If the arrival time for the processor are different, which means all the processors are not available in the ready queue at time 0. So far, whatever the process coming to the system in the ready queue will be in the time 0. So and some jobs arrive after some times, but in such situations, sometimes processes with the short burst time have to wait for the current processes education to finish. Because in non-primitive SDF, on arrival of the process with a short duration, the existing or the execution of the process going on process is not be halted and stop to execute the short job first. So in non-primitive SDF, the process going on or the process executing, we will not stop or halt, but the process may be stopped while we are talking about the primitive situation when the process are coming to the different time. Basically what happened, this leads a problem which is known as starvation problem. Let me take the very simple example. Suppose from the toll, if you remember the example is started from the toll, multiple vehicle may pass, so one vehicle will take the much time because the vehicle owner didn't recharge fasting. So other vehicle has to wait. It doesn't mean the vehicle size is long or short, but the vehicle may pass very easily, but they may already their fastag was already recharged, so but they are not able to move because of the reason, because first process is already taking the too much time. So it may lead to starvation problem, and this problem can be solved by the aging. We'll discuss on what is the aging technique we will discuss, but we have to listen to some basic concept or idea in our mind to solve the problem. So now what we have seen the FCFS and shortage of first followed by the non-primitive. These are the two algorithms we have seen, but we have to cover the primitive shortage of first. So we need to understand the problem. What is the problem non-primitive we have? So I'm repeating second time. In the non-primitive, we have when the all the processor coming at the same time, there is no problem. But the processor coming to different time, then how to tackle all these things? That is coming to this point. So primitive process may interrupt. So this interrupt we can manage of this interrupt we can manage by the mechanism. But this, if you're not able to manage, then starvation problem may happen. And to manage such problem, we have to follow the aging techniques. We will see. Don't worry about this one. So when the starvation problem exists, so shorter process has to wait for a long time until the current longer process gets executed. So this happen if a shorter job keeps coming, but this can be solved by the aging technique. I'll tell you. So no need to worry about this one. So I'm suggesting to the students, let us see the very simple example when the processor having the arrival time. So with the processor having their own identity along with their burst time, but parallel burst time, we have to add one more thing that which is known as the arrival time. So arrival time, all the processor are having the arrival time 0, so no need to worry. The process may be start by the non-primitive approaches. But when the processor are having the arrival time different, then at the time we have to manage the primitive approaches. So let me share my PPT, or let me continue this point. So I'm just moving to the example. If this numerical is clear, so this one. You can note down this problem in your register notebook or copy, whatever you have. You have to note down this question and you have to solve this problem along with me. So you will understand the problem very easily. So we have an example. First example, non-primitive shortage offers. But here we have the arrival time. In non-primitive scheduling, once the CPU cycle is allocated to the process hold it till it reaches to the waiting state or terminated. This is only the important point you have to remember. You can note down this problem, then I'll tell you something about this problem. Then we'll discuss something more deeply. Okay, note it. Note it down. Okay, note it down. So we have the 5 processes. Each process having the burst time 62834. So now what is the burst time? I will not repeat. Already we have seen what is mean burst time, and all the processes are coming to the different time. So let us understand the problem. So at the step 0, or we can say the time 0, the P4 will arrive first and start his education. Tell me yes or no. Process P4 will come or not? Why process P4 will come? Why we have chosen the process P4?
Sir, because the arrival time is 0.
Okay, no problem.
Sir, at time 0, there is no other process to choose. There is only one option.
Okay,
So P4 has the smallest burst time.
this is the answer actually. The process P4 has the smallest, or we can say the least worst time we can choose. But if this answer is correct, this answer is correct till so far what we have discussed. Okay, but here you have noticed over here we have to change our answer. Why? Because in our example we have the arrival time, so we have to choose a process based on the arrival time. So but arrival time, you have noticed over here, P4 is not having the smallest or least time, process P2 having the least time, but its arrival time is a 5. So we haven't choose we can't choose the process P2 because its arrival time 5 is higher than the 0. So arrival time 0, which is holding by the process P4, so that's the reason we are choosing the P4. So we have to keep the statement in our mind why we are choosing. The process P4 arrives and starts its education into the our Gantt chart. We have a Gantt chart. I am preparing the Gantt chart in front of you, then everything will be clear to you. So I will prepare the Gantt chart in front of you, then you can easily understand. So let me explain everything one by one, so your idea will be clear. So P4. So let me first draw the Gantt chart. Gantt chart I'll prepare, and then I'll update the Gantt chart time to time because based on the some correction or updation. So what I'm taking this one first. I'm taking the Gantt chart designing, and don't worry, everything will be clear to you. But you have to listen to my words carefully. Process P4 I'm choosing. Process P4 I'm choosing based on its arrival time, that is a P0, and it will take total time. It will take total burst time is 3. Okay. So far what we have discussed, it is clear. Anyone who need to ask any question, you can please you can ask, else we can continue. This point is clear. At time T0, P4 arrives and start executions. This point is clear. Tell me yes or no. Then I want to tell you something before moving ahead. Tell me yes or no. This point is clear. Why we have chosen the P4? We are selecting the all the process based on arrival time, not the burst time. So this is the role of the arrival time. This point is clear.
Yes, sir.
But you have noticed something over here. So this is the reason I'm changing the color of my mouse pointer. Process P4 will take. You can just notice over here. P4 will take year to year only. So total burst time is 3. So you can notice from For explaining purpose, I'm just showing something for explaining purpose. Just explaining purpose only. You should not allow to write like this way, but I'm for explaining purpose only. The process P4 will take the 3 milliseconds for its execution. So I'm starting by the 0, ending by the 3. This point is clear? Tell me ending by the 3 or starting by the 0. Is it okay?
Yes, sir.
But you can notice this is a time with respect to the time. So all the process will be executed. So you can notice at the time t, I'm just marking over here. At the time t, at the time p1, process P3 was interrupted. P3 was interrupted to the process P4. Okay. So what you're noticing over here? At the time T1, process P3 arrives, and but P4 still needs 2 more execution to complete, but it will continue. So what happened? What happened? The execution of the P4 will not be completed. Its execution will be partially completed. Is it okay? Tell me yes or no.
Yes, sir.
And same time
Yes, sir.
same time two. So for helping purpose, I'm marking over here. Then I'll explain more deeply. No need to worry. So here what happened? Here process P3 interrupt. You can notice over here at the time T2, process P1 interrupt. But still, these two processes are interrupting the process P4 for its execution. So our execution of P4 will not be completed. So at the time T2, process P1 arrives and it's added to the waiting queue, and P4 will continue execution. So here I need to know the process P4 will continue or not.
Sir, P4 will continue because this is non-preemptive scheduling algorithm.
Yeah, this is a very great answer I got from the student. I'm writing here those students, those who are not taking care of my word very seriously because of non-primitive nature. I'm writing in front of you. Non-primitive nature. P4 will not stop or will not be stopped or halted. It will continue its execution. So when we are interrupting this one, we are removing the P4. We are allow the P3 we should execute and P1. Then it is a primitive. But as a per the nature of the non-primitive or cooperative, once the process come to the system for execution with respect to time, the other process has to wait. So what would be the other parameter would be? I'm explaining over here. Let me add the one more slide for more explaining purpose. Here what we have to do? Process P4 will be continue its execution 0, and what is this one 3. But at the time T0 process P4 was started. At the time T1 arrival time, we can say which process coming P3. Okay. At the time which process coming at the time T1 P3, and the time T2 which process coming P1. So during such period, you can notice from here When the process P4 started at the time T0, at the time 1 over here, process P3 will come and check the existing process is going on or not, the execution of the process P4 is going on or not. If the process execution is going on, then it will not interrupt. So this process has to wait. Okay, so this process will be into the waiting queue. And next one, it is notice next time T2 over here. Okay, this is the time T1 and this is the time T2 for the same purpose only. So, but process P4 is not completed, execution is not completed. So this process also has to wait. Why it is required? P4, the execution P4 is going on. Execution going on. So far this point is clear. Tell me yes or no. Then because every step is more important along with the arrival time. So far this point is clear. Yes. Anyone who need to ask any question so far? Yes. Anyone? Tell me. Who need to ask any question? Yes. Tell me. Yes. Anyone who need to ask any question? Tell me yes or no. So shall I continue? Yes. Tell me yes or no so I can continue. Else, yes. Tell me.
You can continue, sir.
Okay. See, I need the response. Okay. So you can notice arrival time 3 is not mentioned over here. And at the time of the time 3, our P4 is finishing. So our P4 will continue. Sorry, the education will be completed. Education will be completed at time T3. Okay. So now the point is over here. In the waiting queue, these two processes are waiting queue. So which process should execute first, P1 or P3? So which process we need to execute first, P1 or P3? Tell me. Which process, P1 or P3?
P3.
P3 then Y and P1 then Y. There is reason.
It is in waiting queue.
It was a waiting queue. Both are in the waiting queue. See, I have just marked it a circle.
First in,
Both,
first out.
yeah, first in, first come, not first in, first out. So if you remember the my words or examples, as I told you, you can just understand the words over here. If the scheduling algorithm is optimal, if all the jobs are available at the same time, arrival time 0 for all, arrival time same. Okay, so here I told you. Yeah. Yeah, this one. I was here. So when the two both processes are having this in the waiting queue, then we need to select. Then we need to select a process based on FCFS. So according to FCFS, which algorithm, which process come to the system? P1 or P3? So which is smaller job, P3 or P1? Tell me, which process has the smallest burst time? So we need to select the program based on the FCFS, but what is the parameter? So we need to select the process based on the FCFS, uh, followed by worst time. So P3 just has a 8 and P1 has a 6. So why I should choose P3 even though P3 has the arrival time 1 while P1 has a worst time 6 but arrival time is 2. So I need to select the P1 or P3. Tell me yes or no. Tell me which one I need to select. Tell me which one I need to select, P3 or P1.
Sir, P1.
Why P1? Because it has a lesser burst time than the P3. Okay.
Yes,
So
sir.
we need yeah. So we need to select the P1. So now P1 come to the our this Gantt chart, and it has a burst time 6. So total would be here 9 over here. So 9 is the completion time of the process P1. So in our waiting queue, see this is completed. Okay, time t0. P3 is not completed when it comes to time t1. So it would be into the still in waiting queue. So now P1 is completed. So next time I'm taking T3. Okay, T3 is not available. No problem. Next is T4. So at the time T4, which process coming? P5. So process P5 will come. So here time T4 there is no issue. At the time T5 process P4 P1 will come, but it would be into the waiting queue. Why it would be waiting queue? Because still the execution of the P1 is going on due to P1 is executing. And now next time T5 we have a next process P2. T5 that would be the process P2. So at the time T3, T4, T6, 7 and 8, just for understanding purpose only, small way, it will also be in waiting, and due to still P1 is executing. So what would be our waiting order right now? What is the waiting order? What would be the waiting order? You can just notice over here. P4 is completed, P1 is going on, so P3 is in waiting, and now then P1, sorry, P1 is going on, not T4 at the time T4, T4 P5. Sorry, I need to write correctly. P5. Let me write correctly. Yes, this one. So P5 and then P2. So this is the waiting order of the our process. These processes are into the waiting queue. So after the P4, P1, which process will need to select from the our waiting queue based process. So from this point, we need to select the process based on based on lesser worst time. So now, which process should come here into the our diagram? Which process we should take? Tell me. P3, P5 or P2?
P2, sir.
P2? P2. Why P2?
So because it has the least burst time.
Yes. Because P2 has a 2 milliseconds burst time compared to the P1, this one, P3 and P5. So we have to add here P2. The education of P2 will be continue. So no more process are required. So no other process will be into the waiting. So we will need to continue from the uh, education, and we'll pick the processes from our waiting queue only. So it has a 2, so it would be 11 over here. Okay, and after this one, what are the next process? Let me just change the color for understanding purpose only. We am just selecting this one. So now uh, this one P2 is completed. So now competition will be the between the P5 and P3. So now competition is stand between the P3 and P5. So in the P3 and P5, which is smaller, P3 has a 8 and P5 has a 4. So we need to pick which one? P5 based on lesser worst time. Okay. So P5 we need to select. So we have to select the P5. So I'm selecting here P5, and it has a 4. So it would be 15. And now which one is the left so far? P3. And P3 has 8. So that would be 23. So now this step is clear right now. Tell me all these steps is clear. Yes, tell me. Anyone who need to ask any question here over? So far, what are the steps I have taken? It is clear to everyone, or anyone who need to ask any question? Tell me. Anyone who need to ask the question? Tell me. Then we have a very very interesting point over here in the next slide. If this point is clear, then we have the next very interesting point.
So can you please just quickly repeat everything in the solution?
Okay. See, process queue. We have the process here. We have a multiple processes over P1, P2, P3, P4, P5. We have the burst time 6, 2, 8, 3, 4, respectively arrival time. So in such case, what happened? We are talking about the non-primitive algorithm, which is shortage job first. So as the name suggests, shortage job first, we need to pick the shortage job. So shortage job means the process which is having the minimum burst time we need to pick. So now in our example, the one time is added, that is arrival time. So in our problem, the arrival time is added. So the process will be selected by the arrival time at what time the process may come. So you may choose the process P4 of P2 first based on its first time, that is P2, no problem. But what happened? Its arrival time is 5, which is higher than the arrival time 0. So process 4 is having the arrival time 0. So we need to select the process P4. So you can notice over here, if I'm selecting the process P4, then its arrival time is 0. So it will take the 3 milliseconds to execute its instructions. So the process will take the 3 milliseconds, but in between you can notice when the time running, so other processes are intervening, other processes are interfering its execution. So you can so notice this diagram. So when I'm just mark the 1 and 2 only. So what happened at the time T1, the process P3 want to execute, and now at the time T2 process P1 want to execute, but still process P4 is not allowed to do so because this concept is non-primitive. Non-primitive is telling to us once the process come to the system for its execution, other processes are not allowed to do so, even though the process has to wait. So in such case, the process P3 and P3 and P1 has to wait over here. So here in our example, you can notice, you can just see this diagram. So P4, so time T0, P4 and time T1, P3 is coming, and time T2, P1 is coming. So P3 and P1 has to wait because the execution of the P4 is going on. So other processes are not allowed to execute its instructions. Why? Because this algorithm we are following by the non-primitive or non-preemption approach. So P3 and P1 would be in the waiting state, but the point is over here when the completion after the completion of the process P4, now P3 and P1 will we decide which one we need to pick one. So as a being user, we don't have a right to do so. As a kernel or the with the operating system, which process need to decide. So you can notice over here in the technically we have this conceptually we have the term when the two processors are in the waiting queue or more than the one processor in the waiting queue, then we need to pick the process based on its worst time. So in the waiting queue where the two processes are having, we have the P3 and P1. So we need to pick the process P1. Why? Because compared to the P1 and P3, you can notice over here, you can see my mouse pointer. P1 is having the burst time 6, while P3 having the burst time 8. You can notice, see, you can over here. 6 is smaller than the 8, and 6 is the worst time for the process P1, and 8 is the worst time for the this one. So which process you should take? P1. So this is the only reason I'm taking the process P1 over here. At the time T3, no, it is not applicable because at the time T3 or no process was arrived. But at the time T4, process P5 was entered into the system. But it is notice P1 has a bus time 6, so it will take 6 milliseconds after the 3 because 3 was a its waiting time because P4 was completed after the 3. So what happened? We need to add this one 9. So you can notice at the time T4 process P5 will not allow to execute. Same for the T2 because still the execution of the P1 is going on. So when the educational process P1 is going on, so the process which are into the waiting, the process has to wait. So previously, which process was in the waiting queue? That is P3 all on. So now P5 and P2 we need to add into the waiting order over here, or we can send into the waiting queue. So you can notice over here, as I have mentioned over here, you can see my mouse pointer. So we need to select one process one by one because no more processors available. So let's see the select all the process. So when we're picking the selecting the process based on is this one was time. So here among the P3, P5, and P2, you can notice over here which process having the least worst time. So you can notice P2. Why P2? Because P2 having the worst time 2 only. So if I compare this one 6, 2, okay, sorry, not 6, 2, 8, and 4, 2, 8, 4. So definitely I need to identify P2 is having the bus time that is a 2, so I need to pick the bus I need to pick the or choose the select the process P2. So this is the only reason I'm selecting the P2. So I'm just mentioned the P2 over here. So now it has a 2 bus time, so it will be added over here. So 9 plus 2, that is 11, we say. So 11 would be the completion time. Now, after this one, P3 and P5 we have. So now P3 and P5 is not executed so far. Still these are into the waiting queue. So now both are ready to execute. So when both are ready to execute, so we need to pick the P3 or P5. This is a competition we have. So you notice over here, P3 and P5 among between the P3 and P5, we need to pick the P5. Why? Because P5 is having the lesser worst time. What is this one? You can notice over here. What is this one? 4 is lesser than 8. Okay, so 4 is lesser than 8 means 4 is the bus time for the P5 while P3 having the bus time 8. So we need to pick the which one? P5. So I have selected the P5 over here. So I've added the 11 plus 4, that is the 15. And now last no more process except the only the P3. So P3 will be our system for executed purpose. So now the P3 will be execution completed. So it will we need to add 15 plus 8, that is with 23 only. So these are entire steps we have taken for the non-primitive. So this is clear right now? Tell me yes or no.
Yes.
So here I want to tell you something. Here I am just drawing something. The our final Gantt chart. Final Gantt chart. Please remember this statement. You have to solve all the problem in the examination like this way. So final Gantt chart we are getting. Final Gantt chart. Please note down the final Gantt chart we are getting. P4 first we are taking. Okay. P4, 0 and 3. Next P1. Okay, this would be 3 only. P1. What is completion time? 9. Next, what we have? P2. So P2, 11. Now next we have P5 and then P3. So 15, 23, P5 and then last P3. So see, this is what actually so what is the completion time? Completion time for a process P1. What is the completion time? Tell me. Tell me what is the completion time of the process P1, P2, P4, P3 respectively. 9. P2 completion time is 11. P3 completion time. No, sorry. P3 completion time. Let me remove. P1 we have, P2 we have, P3 completion at 23. P4 completion time we have 3. And P5 completion time is 15. Now this is clear right now?
Yes, sir.
So what is the formula of the turnaround time? If you remember the other parameter, as I told you, turnaround time, how we can get it? Completion time minus arrival time. So turnaround time, okay, TAT, I'm writing turnaround time for the process P1. So for the process P1 would be completion time 9 minus what is the arrival time? P1 2. Okay, so we can subtract 2, so we can get the same one. Turnaround time process P2, what is the it's 11 minus, and what is its arrival time? Tell me. It's 5. So we can just go like this way, 5. So we have a 6. So P3, P4 and P5. So P3 we have completion time. We can write the completion time P3 23. P4 we have completion time 3. P5 we have completion time 15. So P3 it has arrival time 1. Okay. So arrival time we have 1. So 24. And P3 P4, what is the P4? P4 has arrival time 0. Okay, 3. And P5, what is the P5 arrival time? 4. So
Sir,
that is
23 minus 1, 22.
just 1 second. Let me. I'm correcting. I'm just correcting. No problem. Thank you for correcting this one. Yeah, it was a writing mistake. So it would be 9. So we are getting 7, 6, 22, 3, and 11. Is it okay? So in the exam time, I may ask to completion time, turnaround time. Then you have to calculate. Okay. So now I'm sharing one slide which will have all the information. So P1 has the completion time 9. So turnaround time we are getting the 7. But how we are getting 9 minus 2? So how we are getting the completion turnaround time for the process P2? 11 minus 5. So here 23 minus 1, 3 minus 0, and 15 minus 4. So waiting time we can get by the turnaround time minus burst time. Okay, so turnaround time is 7. 7 minus burst time. What is the burst time of the process P1? You can see in the bottom side. P1 burst time 6. So 7 minus 6. So rest of detail you can get it.